Good day, ladies and gentlemen. This is Sarah van Grennen, aka Mr. VG, and I am now into this video about perpendicular lines, one of the most amazing applications of gradients in all of mathematics. Now, perpendicular lines have got a lot of uses, from Pythagoras to trigonometry to areas. Oh my, so many applications. But let's look at the basics of perpendicular lines by looking at this first example. If A is 2, 5, B is -1, -1, and C is -3, 0, would AB be perpendicular to BC? So that is a very, very valid question. How would I know whether they would be perpendicular? Well, they're perpendicular if the gradient of AB times by the gradient of BC is equal to -1. So in other words, I need to get the gradient between A and B, the gradient between B and C, and then multiply them. If the answer is -1, well, then I have that the two lines are perpendicular. If not, then it's not perpendicular. So let's go for it. The gradient between A and B, by substituting into my gradient formula, is -6. If I get the gradient between B and C, by again using the gradient formula, y2 minus y1 over x2 minus x1, my answer is -1/2. Now let's go and multiply them like it says on the left-hand side of your formula. If I multiply the -6 by the -1/2, my apologies there, my answer that I get is +3. Now that is definitely not equal to -1. And hence, the two lines are not perpendicular. As simple and as easy as that. But again, wait, there's more. Maths doesn't stay easy. Where's the fun in that? So what if I give you this next sum? It is given that the line segment between A and K is perpendicular to the line 6y minus 3x equal to Juan, my favorite Mexican, Juan. Calculate the value of P. Now this is a beautiful, beautiful sum. But I've got to start at the place of perpendicularity. That's a very important one because it guides me towards where I'm going. So if I look at the gradient of the first one, and I times it by the gradient of the second one, my answer is equal to -1. So I need the gradient of that line. But I can't get the gradient of the line unless y is the subject. In other words, y must be on its own. So therefore, I'm making y the subject, so I'm getting y alone, because this tells me that the gradient of that line is 1/2, and the c value is 1/6. I'm not going to worry about the c value. I want that m value. Why do I want it? Because I'm going to use it with the gradient between A and K by simply using my formula. If I simplify my formula, I get -7/P. Now, what does the perpendicularity say? It says that the product of those two gradients must be -1. If I try and solve that, I'm going to just multiply the numerators and the denominators. I'm going to multiply straight through by the 2p, and I'm going to solve p. So therefore p must be positive 7 over 2. My apologies for making it negative 7 over 2. You see how quickly mistakes happen? But that's sometimes because we lose focus. It's always good to take a step back and go, but a negative divided by a negative gives me a positive. So my answer must be positive 7 over 2. So this means if P is 7 over 2, then the line segment will be perpendicular to that line. As easy and as simple as that. This was a kind of a tricky one. So please make sure you go back to why did I have to get y alone for that line? Why did I use the gradients? It's worthwhile giving this a second look, trying it yourself and seeing why I did that. This is Mr. VG signing out. Look out for our next video on determining the equation of a straight line. Keep well. Cheers.